Okay, hi guys. Let's talk about the Splunk AI apps and add-ons. So there are three important ones which I have picked up to discuss today, and also that is our agenda. Splunk AI Assistant, Splunk MCP Server. MCP refers to Model Context Protocol. Another is AI Toolkit. So AI Toolkit is formerly known as Splunk ML Toolkit, which means Splunk Machine Learning Toolkit. So MCP is not something specific to Splunk. Okay, here. So MCP means something where you can securely access the data within the client environment and to expose it to the external agents. So this is widely used for building agents and all those stuff. Let's move on. First, let's look at a quick view of what is AI and how we can relate it to a human. Okay, because and before we go ahead and discuss this, do we really need to know these things? Yes, definitely. Because in the AI era, we have to be always one step ahead, or at least we should walk along with the AI things, whatever that are happening around. You might have observed or seen there have been a lot of layoffs going on and all, right? So let's try to be one step ahead compared to the any of our team members or anybody. Okay, so just to stay ahead in this race, we have to be at least aware what is these apps and what they are trying to do. We should be aware at least that what is the purpose of these apps. Okay, later we can start working on them, test them, we can learn them. That is the secondary part. First thing is at least we should know what are these apps available in Splunk and what they are doing. So let's now compare this AI with our human. Okay. So data, whatever we have, we are collecting the data that is, we can refer it as senses, which means where you are collecting the information. So let's say if I am a human, okay, if I'm going to touch something that is too hard, so I could sense that automatically. That sense from the fingertips will be sent to the brain, right? So that sense is actually called data and nerves. So what are these nerves? From my fingertips, these nerves will carry the information to my brain, says that, hey, there is something you touched which is hard. It tells your brain, it passes that information. And brain is where all the information is processed, taking decision, all this kind of stuff will be happening on the brain. So if you compare these first three things, one is data is what you see, what you sense, and nerves is neural network, which are carrying the information, passing the information. Brain is AI model, okay, learning. So what is your brain doing here in this example what I have taken of hot? So when you touch something hot, so you learned something that, okay, if there is something like this item available, this is hot, so you have learned something. So in the similar way, as you have been growing up, you are learning so many things. Okay, this is something hot. This item is something cool. So you have trained yourself. You trained your brain yourself better. So you have lot of things which are hot, which are cold, which we have to touch, which we should not touch. So that is something called training. The more training you are doing on the more data, the perfect that model is going to be. So in the similar way, if we have so much of information, so we are going to be more perfect or more accurate. Okay. So obviously we are going to, it is going to store that whatever the things we have experienced in the memory, right? So that is called trained model. So a trained model is something, let's say in a simple terms, there is a huge library. Okay. So we trained one person with the knowledge of each and every page of each and every book in that library. So he's a trained guy and he knows each and everything about piece of information available in that library. Based on that, you can take decision or you can respond. If I go and ask that guy who has learned everything from the library, he should be easily able to answer me because he has already trained on that data. So that is simply human to AI relationship with an easy example which we can understand. Let's move on. So as I told you, AI Toolkit, AI Assistant, MCP Server, these three things are going to be our agenda mainly today. So AI Toolkit, which formerly known as Machine Learning Toolkit, it is mainly focusing on machine learning models. Okay, you see a lot of machine learning SPL commands which actually use Python in the backend and give you lot of models, lot of algorithms to train your data, to forecast, also to predict. So all these kind of things you can do using AI Toolkit. Second thing is AI Assistant. AI Assistant is just like a Chat GPT or Gemini. You just ask something in natural language, it responds to you with some piece of information which is available in the external internet. But what happens with Splunk AI Assistant is, so this app we are going to install in the Splunk Enterprise or Splunk Cloud. So what it should be capable of doing is, it will be able to access the data which you have in your Splunk Enterprise, and it will be able to help you with queries. Or if you want to ask some question about your query, let's say you have 30 lines of query and you don't know what the hell is this doing. So you simply paste that query, 30 lines of query, and ask what is this query doing, and I want to make some small changes like here and all. So it will give you that query. Okay. So MCP server, Splunk MCP server is also a dedicated app, which is mainly focused on the same purpose again. It will have all your Splunk data, and what it can do is it can securely expose us to external LLMs or any, if you want to build an agent which is actually working outside of your Splunk instance, so then you need MCP server access. So we will discuss in detail about all these three things in the coming sections. Splunk AI Toolkit, as I already mentioned, which is formerly known as, Splunk ML Toolkit, which means Machine Learning Toolkit. Before we look at this app in this Splunk, let's see what are the main components which we have in the AI Toolkit. Showcase, experiments, models, and connections. So what is showcase? In the showcase section of this AI toolkit, we can see pre-defined examples which will take you through, industry leading examples. For example, prediction of something or detecting the outliers. So those kind of examples are already available, where you can just look at the example lookup file data which is built in with AI toolkit, so you can understand how this is going to work. Okay. Experiments is one thing where you can upload, you can run the data what you are having, you can experiment on it, and you can train your model based on it. Okay, you can fine tune your models to meet exactly, to meet the right predictions based on the training data that you are going to do. Models are like, you have predefined models in Splunk already, and if you want to add some other models from external such as AWS SageMaker, and also they are going to add more and more in the upgraded versions. Right now, as an example, I can tell you that AWS SageMaker is one of the model which you can add. So what happens when you add, let's say, SageMaker? So you are not running it on your Splunk local machine. It is not going to utilize any of your resources here. It is going to run in the AWS SageMaker, which means outside of your Splunk. So it is not going to affect anything on computing point of view. It is going to run outside your Splunk instance and going to give you the results. So that's what about third party models. Whereas when you are choosing the model that is built in within the Splunk, what happens is those models will run on your Splunk environment. Connections. So connections is going to be quite famous nowadays because uh, when you nowadays everybody is building agents, okay, right? So using these connections you will be able to build agents on this Splunk. You can also connect the external LLMs. LLM means large language models, which majorly we use for chatting and all. So, for example, ChatGPT or Gemini, you ask them something in a natural language, and they respond you with some response along with proper content and some detailed manner, right? So that is what you can do with connections. Let's look at the app so you understand it quite better. Just give me a second. Now you can see my screen, right? So here I just logged into AI Toolkit. All right. So showcase section, experiments. You have a model drop down, agents, connections, lot of things. Agents is not yet available for everybody. This is some exclusive thing which I am having here. So just ignore this agent section at all. Okay, you will not see these agents maybe, or maybe you don't see the options which I am able to see here. Okay, forget about it. They are still working on it and they haven't made it public to customers. So welcome to the AI Toolkit Showcase. Watch and learn from the interactive end-to-end examples, as I already mentioned. So you can select this by category. Let's say if you want to choose by the category like LLM, if you want to work something with LLM or prediction or detect outliers, you can select. And when you select, you will be having lot of examples under it, and you can choose which example you want to check and use. Or if you want to go by industry, yes, you still have this. If you want IT or security, business analytics, IoT, okay. So the same things are available in industry also, but the difference is it is easily categorized. So if it is something related to security, anomaly detection is there. If you go to ML operation, that anomaly detection is, find anomalies is available in the detect outlier section. So it's the same thing. You have all the models here also, and in the industry section also, everything is same. So for when we want to work with LLM, it should go to some external LLM models only at the moment. Splunk is not having their own LLM model at the moment. Okay. So let's pick up something like predict fields. Let's look at something. Let's go into predict disk utilization. Okay. I want to predict the utilization of my disk. So this is one lookup file which is already available, which comes along with the AI toolkit. So you don't have to worry where you need to find out and all those things. So it's having all this data along with some times. Okay, I ran it with all time. Okay, so this you have three sections here: define, learn, review. So as I already mentioned, let's not look so much in depth into what is this doing and all. Let's look only from the perspective of a Splunk engineer. Let's go to next. The data is loaded, right? Okay, let's go to next section, which is learn. So in the learn section, you can see you have all the details here. You have no idea what all these options are. Okay, no problem. Let's first look at very basic details. Failed to Field to predict. Which field you want to predict? Okay, I came here to predict disk utilization. So you can select it. I want to predict on disk utilization. And based on which fields you want to predict it. So I want to see totally how many disks I have accesses and how many blocks are available. Based on that, I want to predict the field disk utilization. So, in simple terms, field to predict could be number of people logging in. Okay. Predictor fields would be, let's say, if there are 10 people logging into a particular website. So that website is working fast. Everything is okay. Let's say all of a sudden 1 million people logged into that particular website. Then what happens? The number of people increased, so the performance of the application is going down, which means that may respond slow. So that is what. So if number of people, we will select in the predictor fields, we will select if the number of people and what you want to predict. I want to see the response time of website if more people are logging in. So that's a basic example, right? Here what we are selecting based on disk access and disk blocks, I want to predict how disk utilization behaves based on these two fields. And here is the main thing, training slash testing. So based on whatever the data which is already available, what we are telling is 70 by 30, which means 70% of the data in this lookup used for the training, and remaining 30% we are asking to predict the 30% of data. So what is happening here is, so 1 2 3 4 5 6 7 8 9 10. So for example, let's say this is the data you have in your lookup. What we are telling is we are training that model on all this data until 7, and we already have 8, 9, 10 in our lookup. But what we are trying to do is, in terms of this training, what is happening is we are deleting it. Only from this 7, we are trying to predict the next 8, 9, 10 values. Okay. So when I click on predict, you will understand it better. So now it is running. The model is running. I haven't selected anything here. I just came, whatever the details were already available, I just clicked on it. So now you see we had input, output, and now evaluate. Here there are two things. Let's not worry so much about it for now. Because we just want to see what is this AI toolkit and all. So R2 statistics, in simple terms, I'll tell you R2 statistics means the number you see, right? 0.99, 0.99. So if it is close to 1, that means the model is that much perfect. If it is 0.99 is very close to 1, which means this, whatever the prediction it has done, it actually did a very good job. It predicted very proper values. And this RMSE is there, right? The lesser number you have, that much good that model it has actually predicted. You see, this testing is actually having 1.6, which means it's not good. If you have 0 on this root mean square error, that means that's actually working great. So these two are the parameters which we use for how I can say, to train our model, fine tune our model to meet exactly the right predictions based on our data. Let's look at sorry, not this one, output, what it has actually given as the output. So total disk utilization at this particular time, right? It was already available 0.0, and it predicted this value. So predicted value will also come in the output. So in the evaluation, what we are checking is how accurate that model is predicting. Let's say I am going to make it 97. Okay. See, this is 1.6 and this is 0.87. Let's predict now with 97 error while saving the model. Some error has come up. Let's move it to 90 and let's predict. Don't know what that error is. I think there is some limit when I'm trying to use this. Okay, fine. When I moved it to 73 from 70, it is actually trying to predict. Fine, let's see. It is still good. From 1.6, it has become more 1.98, which means it is actually behaved bad with 73%. Let me make only 10% of the input lookup file for training, and I will give it 90% for prediction, which means actually not good. We have given very less data, which means we gave 1 hour of data and asked to predict rest of the data, which means for the entire year we asked to predict. So it is obviously going to behave worse, right? That's why you see 2.33, which means it's more. When RMSE is more means it is actually behaving bad. Let me give just one record. I just give one for training and rest 99 for prediction. You see, it's 12.35, and even this number is also not close to 0.9 this time. The testing is 0.6, which is very almost half of this what we expected. So the more data you are having to model, the better it will learn and the accuracy will also be better. Okay. If you want to view the same things in a different visualization, you can see it. If you look at scatter plot, it looks really actually good. Let me zoom in. What is happening here is, this is what your actual data is. And here are the values that it predicted. For example, if I keep my mouse here, total disk utilization is 108 and predicted is 93.18. So you can see in a graphical manner also. And if you want, there is some other visualization which you can see. So this is just for how you want to train and fine tune. If you want to fine tune your algorithm itself, so algorithm is something different and model is something different, guys. So in simple terms, algorithm is the having the ingredients, okay, and model is actual recipe. So you have all the ingredients here. So based on how much you put in the ingredients, let's say if you are making a paneer, if you are only going to put paneer more, so you are not going to get the proper food item output. So you have lot of options to fine tune your algorithm to make that prediction better. Okay. So these are not fixed. Why they are not fixed means, so based on the model you are going to select, based on the food item you are going to select, the ingredients are also going to change, right? So in a similar way, for each model you have different ones. So if you don't want to get confused so much, just try to fine tune these, but your ultimate goal is to get these values more close, this value more close to 1 and this RMSE value as less as possible for better accuracy. That is the end goal. Okay, let's go back to, okay, let's click on, I think it will fail because earlier also when we selected 96, okay, when we select 96, I think there is some memory issue that I'm having in my instance. Fine. So you can have this in your Splunk Enterprise free instance also. You can just play with it. And when you come to the review section, right? I just clicked on next here. That's it. Okay. Predictor importance. And there is also one other section you have what if analysis. So here it's really great, right? Even though it is at the last step, I feel that it should be prior to where R2 and all those things place. Why is, let's say, AC power. This is also one of the field. If AC power is 218, what if this AC power is 321? How it is going to predict? Total disk utilization is going to be 199.4. So based on the model you have already built, so this is how it is going to predict. Okay, you already built the model, you selected 70% training data, everything you have already configured, and you felt that okay, my model is working great. Then in the next section you can just cross verify, okay, on the same model itself, if I am having a AC power 218, how it is going to impact on the disk utilization, I mean like how it is going to predict. And that's it, you cannot save or you can't do anything here, you just have a back option here because we are just having a showcase where you have predefined examples and that's it. Okay, so if you want to summarize on the data, you can do this LLM integration option, but what happens is it goes to AI command, and unfortunately I don't have this LLM configured because I don't have any of in access to the external environment. That's why I don't see it. Otherwise, what happens is, so till this place, whatever the data has loaded, then we are prompting, please summarize these error messages and describe why I might have missing. It is simply you are going to attach a file of events to ChatGPT and you are asking this question. I want to summarize them now. That's it. Okay. Okay, let's go back to experiment section now. So experiment section, you can actually do more of the same thing. Showcase where you have predefined examples. Let's go with create an experiment. Even in the experiment section, you can select which of the category you are actually trying. So most you see smart prediction is there and predict categorical fields and also forecast time series. You might feel that okay, everything is actually doing the same thing like forecasting or predicting. Maybe it may sound similar, but it's not the same case. Why? Because as I mentioned, different models are made for different purposes. If you look at this forecast time series, so it is focusing more on the time based events, time based predictions. So that's why you have to select the very right thing which you want to do. Let's say I'm going to talk about these experiments and I will select one forecast time series experiment. Okay, I don't have anything at the moment, so I will create an experiment. I want to predict on the weather. I created the title as weather. Okay, so now you have experiments, experiment history. Let's come to that experiment history later. So you can enter your search. So what it means, you can actually pull your Splunk data. In this Splunk instance, if you have actual data of your client, you can simply run the search, get the data, and do all these experiments. Okay. So right now I want to walk you through with an example. Let's search for the data. How it looks is I have a weather data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 rows of data. Okay. These are the temperatures I'm having. That's it. So now you see there is a drop down of algorithm actually. So let's say for example, as I mentioned, algorithm is like the list of ingredients. maybe I have Kashmiri chili in one of the algorithm, and there is another Guntur chili in another algorithm. So like that. So the whatever the algorithm is fitting best for you, you have to just play with it, fine tune it, and do all the stuff. So if here when I selected Kalman filter, you see method, future, time span, hold back, confidence interval period. If I select ARIMA algorithm, I see something AR. Integrated D. So I have different options. So as I mentioned, every algorithm is different. You need to just play with it, fine tune it, and do the best one for you. So I'll just select this one. I have field to forecast. Of course, I want to look forecast on the temperature. I'm not selecting anything here. So I'm just doing clicking on the forecast. That's it. So you see, if when you keep mouse temperature actually is 74. Predicted temperature is 74.64 and conf underscore interval temperature is something. So I don't understand because one is at the top. It doesn't fit. You see, if forecast is shown in this dotted lines, temperature, actual temperature from the data is like this. And this thing is actually what how it forecasted. Till here you have your data, right? So future time span. So based on this future time span, it actually predicted all these values. 5. If I make this future time span 0 and if I click on predict, yes. Okay. So it is actually not predicting anything because we just made it 0. So here actually I use this experiment section earlier. That's why you see confidence interval 0. 95, sorry. It by default when you open it for the first time it will be 0. Okay, which confidence interval is something like we are telling the model, okay, I have no doubt on it. I know you are the best. Just take decisions on your own, predict on your own, and all those things. If we are making this number less, like let's say I have only 50% confident on you, I just do the prediction carefully. So that is what you control with this confidence interval, right? You see, if you keep a mouse, you get a tool tip here. Specify an integer between 0 and 99 where larger value means a greater tolerance for forecast uncertainty. I made it 0, which was by default. I'm just clicking on forecast again. Now you see the better result, right? And also I want to do the forecast for future. I just kept 5. I don't know what that actually means. Okay, that doesn't matter for now because we are just doing these experiments and all. So you see it look better, right? So like that you can do. You see something called method is also available within the same algorithm. You have different kind of methods again available. You can just play with those methods, whatever is fitting better. You see, this is almost aligned to what you are having in the query. So maybe this looks fine to you. You see, R2 statistics is 1, which means I think this is fitting the best. 0, the lowest number of RMSE means this is the best. Okay. So there are forecast outliers also you can see, but right now we just have 10 datas here. So we will not have anything. When you have actual data, so you can do the better forecasting, better testing and all those things. So if you want to use this graph of forecasting somewhere in your dashboard, you can see the show SPL. This is what actual data we have given and this is what it has performed. You can copy the SPL, okay? Or if you want, you can simply open in search. When you click on open search, it will run that search. So what is extra it has added when we are doing this experiment? Predict. It used the predict command. It is a model, okay? So model means in simple terms within Splunk, it is a Python command where it has a lot of libraries, lot of imports, every prediction, all those stuff in the backend. When you do run this predict command, it is running that model automatically, and you have all those settings here. You see, future time span is 5 and all. You can simply copy this copy this query, put in the dashboard, report, or alert anywhere you want. That is as simple as that. Okay, and that's it. You see, now let's look at the experiment history. So after doing a lot of experiments, you might felt that, oh, actually I did this. Let's say you tried 20 settings here, predict, forecast, but you felt that the second time whatever the experiment settings you selected, they were perfect. So you can still get them from the experiment history here. You see, you can simply go and check. You see, 1, 2, 3, 4, 5. 5 times we clicked on forecast. So you can get forecast and you can directly load the settings. So if you click on load the settings, so for the first time, whatever we have run, those settings are applied. You see, 95 and 5. That's how you can do with it. You can take a help of experiment history. And now what else you can do? You can actually delete. Let's forecast. Let's save this forecast. Let's delete this. I don't want the confidence interval to be 95. Okay. Now I will simply save it. Yeah, I'm just going to do the same thing. Now let me go to the experiments tab and see how it is looking there. So now you see how many you have. You have one here. When you expand this, you have the data source and when it is modified and what is the algorithm you're using. Main age, you can create an alert, edit title and description. When you create an alert, you see you're getting a very, great pop-up here. So based on the prediction, if you see if it is going to be 90, if the weather is going to be 90, I want to get an alert. So you can do that thing here. That's the best part. Okay. From the models, you can actually just look at the models. So these are the models which are available. If you want to add a model, you have ONNX. So actually, when you save a model, let's say if you are saying saving a CSV file, it will be in .csv, right? In the similar way, the models are saved in .pkl. I think I don't exactly remember the pkl extension. The other extension is ONNX. So that will be the type of those models. Okay, ONNX model. You can simply upload the model here. So it will be saved in your Splunk. Or if you want to add SageMaker belongs to AWS, right? So you can add the AWS model. It will be running on the AWS cloud backend. Vertex AI model belongs to GCP credentials. So you can add those external models also here. What is the other? You have settings. Settings means you can control and you can see all these algorithms, right? You see so many algorithms which are available here. If I click on something like some more algorithm, just for an example, you can select this timeout, all these settings, okay, sampling and all. So let's not disturb anything which is by default available. If you click on the settings here, what you see is the global settings. If you want to apply something like timeout and all, you can apply those settings globally to all the algorithms. Okay. So connections is one more thing which we discussed, right? Connections. So let's look at the connections. So this is very, very important now because when you are going to add these agents, when you are going to build an agent, which is not at all in the Splunk, okay, from the external world, you have an agent and you want that agent to talk to your Splunk. get the data from your actually Splunk instance. So then you need to use these connections. Okay. When you click on the connections, you see LLM, large language models. So as I mentioned, in the showcase section, you have LLM summarization, right? So if you want to use that, you need an LLM connection here. If I click on LLM, you can select any of the third party LLMs, or if you have a custom LLM already available, you can add it. So if you want to use OpenAI, you can select the OpenAI. You have to give the credentials, key, all those things, endpoint, access token. When you give the access token, of course, you know that it will be asking for the money in your OpenAI. You have to create a token in your OpenAI. That's how you can add LLM. MCP. MCP is the most famous thing now because everybody is using this MCP server and getting the data. So if you want to add an MCP connection of Atlassian, Atlassian is very famous for Jira, Confluence, all those things. If you want to add a MCP server for this, you can add it. Or if you want to look at this MCP connection of Splunk, here you go. So what happens is you actually need a MCP server that I will be discussing in the next section. Okay, right now just look at this LLM MCP, and you also have a knowledge base. You can add a Splunk AWS knowledge base details here. Container. So you can also add the containers and dockers where models can be run. This is dedicatedly about the models, algorithms, all the stuff, machine learning. Okay. Okay, I think that's it for AI Toolkit. So what you can actually take out from this? You have tested a lot of things. Everything is fine, Siva. What is going to be the use for me on this Splunk AI Toolkit? Yes, I'll definitely come to that. But let's quickly have a look. Your data, your data has been actually prepared. Choose an algorithm, train the model, use that model, create an alert dashboard or anything, and get insights to it. So that is what you can do simply with Splunk AI Toolkit. Okay. And you must have Python for scientific computing add-on for this AI Toolkit to run. It should be compatible version with both. Otherwise, AI Toolkit is not going to run because, of course, Python, all the commands, the predict, outliers, all those things are going to run on the Python only, as I mentioned. So what are the use cases? You can predict future metrics. That is an use case. Spot unusual events or outliers. Group similar events or users. So these are the use cases. Just famous use cases I mentioned and takeaways. This is what you can focus. Leveraging built-in ML algorithms to model normal data behavior and automatically flag anonymous events or deviations. So you can go to your client, you can train some model, you can tell him that I can predict the number of people logging in or fraud payments or whatever it is. If you are a telecom guy, so based on what your client is most focused, let's say if I am working for a bank, okay, what I can do is I can create something like if there are more payments on a particular day, more payments are getting failed. So that is something outlier. So based on finding those outliers, so I can use these machine learning things. So I can create a dashboard or report or alert, and so my client will be definitely impressed. Oh, this guy is actually doing something really good and advanced. So we need to utilize and showcase this to customer. And one of another use case could be use the forecasting assistant on historical web visits data to predict next week's traffic, then schedule an alert on the forecast. So an example would be, let's say you are using a database. Okay, there is a particular time where most of the people are going to hit the database or a website or a server or be it anything just based on your customer. Okay, you just create a dashboard or a report or an alert and forecasting, so it will give a good insight that okay, maybe in the next hour something might go down, so let me have a closer eye on it. So we are not going to have a business impact. So these are the two takeaways which you can go ahead and utilize in your client. Okay. So that's it on the AI toolkit. In the next part, we will look at the Splunk MCP Server and Splunk AI Assistant for SPL.